Scientists at NASA's Glenn Research Center in Cleveland, Ohio, are learning how to monitor airline pilots' brain activity to determine when they are operating under dangerous levels of stress, fatigue, and distraction. Their goal is to improve safety on commercial airplanes by helping pilots make better decisions. The team is testing a helmet that uses optical sensors to peer into the brain and detect changes in the blood flow that indicate a pilot's mental state.
So we're monitoring the blood flow in the brain in different regions, and by using that data we can determine what cognitive state the pilot is in. And that's done through an emerging technology called functional near-infrared spectroscopy, and that injects light into the brain, which then diffuses right through the skin, the skull, the fluid, through the top layer of the brain, and we detect it a few centimeters away, and we look for changes in the blood flow right in those various locations.
15 NASA employees and contractors have volunteered to wear the helmet while sitting in a moving cockpit simulator. Test subjects are presented with a variety of distractions and stressful conditions as they fly a virtual airplane.
In this test, we're trying to measure the response of the subjects to different functional tasks, whether those be simple, pure tasks or complicated multitasks. So by monitoring the subject's response to these simple and more complicated tasks, we can get an idea of how they might respond under stressful situations. The goal is to help pilots make better decisions in order to ensure passenger safety. We want to reduce the number of potential aircraft accidents by warning the pilot when they're under dangerous levels of stress.
In its current design, the helmet uses 32 diodes to monitor 16 areas of the brain. The researchers plan to vastly improve the comfort of the helmet and hope to simplify it by reducing the number of locations in the brain that it monitors.
Ideally, in the future, we won't need all 16 locations. It might turn out, and that's part of what we're trying to study here, that certain locations are more important than others to monitor, and that we might get the same answer with less instrumentation.
The research complements that of others working to simplify the delivery of information in the cockpits of commercial aircraft.
As a result of this testing, we hope to develop technology that could be designed into modern-day cockpits that could feed back to the pilot who may be under a dangerous level of stress only the information that is critical right at that moment.
The study is funded by NASA's Aviation Safety Program and is part of a larger effort to improve flight decks on commercial aircraft.